All right, we're going to work through some of the problems on the vector worksheet, starting with number 1. It's all about an airplane flying into some wind. Okay, and so when you fly into wind, it's like swimming across a stream that's moving. You're not going to go straight across the stream. The water is going to push you downstream as you swim across stream. So there's going to be two components to your movement, your swimming, and the water. Same thing with the airplane. Okay, there is a component of its motion that is that northward motion, flying at 135 kilometers per hour, but it's also being blown to the east, which is this way. So you've got 135 kilometers per hour. Man, that's bad. Lagged on me. 135 kilometers per hour plus this motion, 65 kilometers per hour. That's a lot of wind. Okay, those two things, we have to add them together. And how do we add vectors? We add them tip to tail. So if I want to add these two vectors, it's this plus, or we're gonna put them tip to tail. Let me actually just drag them together. So you take the north portion and you put the east portion against the tip of that arrow. And so your resultant goes from the tail of the first vector to the tip of the last vector. Okay? And so your actual motion is in the direction of that red line. So you're trying to fly straight, but the wind is blowing you to the right, and so you go a little bit right of the straight direction. And what do we want to find? We want to find out how much did the wind blow you to that right direction, and we want to find the magnitude of this velocity here. So again, 135 here, 65 here. How do we solve for v? If you know two sides of the triangle, you can find the third with the Pythagorean theorem. A squared plus b squared c squared. So in this case, 135 squared plus 65 squared is equal to v squared. Okay. Break out the calculator. And we've got 135 squared plus 65 squared. And we're going to take the square root of that number. We get 149.8. Rounding to 3 significant digits, you get a velocity equal to 150 kilometers per hour. Okay, so now we have to find the direction. All right, so what we have found is a speed. That's how fast the airplane is moving. But we have not found a velocity, which includes the direction. So as soon as we give this thing direction, we'll have a velocity that's a vector. But right now we just have something scalar, just a number that represents the speed. Okay, so how do we find that angle? We're going to use the trigonometric. We're going to use 65 and 35. This 65 is opposite to the angle. This 135 is adjacent to the angle. So we can use the tangent function, which says that the tangent of an angle is equal to the length of the opposite side over the length of the adjacent side. And the way we solve for that, the opposite of tangent is inverse tangent. We have to do that to both sides. We get inverse tangent 65 over 135. Uh-oh. Alright, inverse tangent. You can do this one all by your lonesome if you need to. At 25.7 degrees. At 25.7 degrees. And then now we want to specify. So 25.7 degrees doesn't necessarily mean very much. We're not going straight north. We are going this would be straight north. We have turned towards the east. So we're going 25.7 degrees east of north. So your first vector is the last direction, east of north. And we'll do another one for number